Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I have two very special guests. Florian, sorry, I got your name slowed down a little bit. It's Florian Gilford, is that right?
It's Florian Gilcher, and I can't pronounce my
Gilcher,
name
sorry.
properly in English either. So any pronunciation is fine.
And Quentin, and I didn't ask how you actually say this. Is it Ochem or Ochem? How you say that?
Ochem.
Ochem. And I believe you're French, right? Because
Yes,
I saw
indeed.
Ada is French. Okay, makes more sense. Sorry, my fault for not asking beforehand. I'm just too excited about these two guests coming aboard. In any case, so Florian, of course, if you should know him from the Rust Foundation and from Ferrous Systems. Quentin is probably maybe a little bit newcomer to the community. He is from AdaCore, right? The name of the company. Is it called Ada or Ada? I've heard it both ways.
In English, you'd say Ada.
But in French, you would say Ada.
In French, you'd say Ada, but Ada is
Okay.
the proper term, I would say.
It's fine. Okay. So the most important thing about this podcast episode, is just to kind of talk about you guys' recent partnership, which is huge. And I said before, I don't totally understand everything, but I do understand this is going to push Rust forward, I think, in terms of adoption to very critical areas that were normally dominated by Ada and like C and some other kinds of languages. So maybe, I'm not sure how we should start this one. Maybe we can talk about I think the biggest thing is this is really, both of you guys are going to be working on Ferrocene, right? Isn't that what I understand correctly?
Yeah.
And so let's talk first, what is Ferrocene so that we can be clear?
Okay, I can start with that. So Ferrocene is, at the simplest level, it's a distribution of the Rust compiler that's geared towards the safety critical market. And there's often a little bit of confusion around what that means. The biggest part of what that means is that customers in safety critical spaces have a lot of requirements, both from how they do their development, but also from the regulatory side. So in safety critical spaces, where you, for example, most of our endeavors are actually in the car industry. So think about something that controls a brake. So you want to make sure that all tools that you're using to build software for your car brakes are of high quality, and particularly that you know the quality of them. That's what's called usually quality management. And there are certain regulations around that. So for example, for cars, there's a standard called ISO 26262, which defines certain levels. So they categorize systems into levels called from ASIL A to ASIL D. And those ones describe requirements for the tools that you use that you check off before you use them. And the main tool that you're using when you're programming is your compiler. So what Ferrocene is making these kinds of assessments around the Rust compiler and ensuring that the compiler is living up to that level of quality. Quentin, maybe you want to add something to that.
Yes, so there's actually a regulation on how you need to demonstrate the fact that your compiler is compliant with those regulations. And those rules can be quite stringent, quite difficult to follow. So, for example, one of the first things that you need to be able to say is, this is precisely the language that I implement. And this is the demonstration that indeed I implement this language the way I specified it. So you need to demonstrate significant amount of testing. You need to document a lot of things that necessary documents in the non-safety critical world, I would say. So Ferrocene will be a distribution of Rust, which will be well identified on a specific version with all the necessary documentation and all the necessary testing and demonstration that make it suitable to be using in those safety critical regulated situations.
I want to talk about what it is to define that. So when I was doing my research about this, I think part of the definition is that if you write your code in this way, then it should be outputting assembly code like this or something like that. Isn't there a way that you have to define it, the way it outputs the assembly code or something? You can prove it or something like that?
Not really. I mean, what you have to demonstrate is the final binary behavior. You usually don't have to document the exact code pattern that you would generate. That would be yet another level of work. Some people do that in some very specific situations. There are some aspects of, for example, avionic certification that might ask you to demonstrate some of that. For example, at the highest level, D178, which is the certification for safety certified software in avionic, is asking you to demonstrate that your compiler doesn't add extra branches in the binary code. And of course they do. So when they do, you need to be able to explain why and demonstrate that you've tested the fact that this behavior is as intended. But you don't quite need to go as far as describing the exact assembly patterns that correspond to the inputs. That would be a daunting task. So what you do instead is to demonstrate that, to test essentially the output and to verify that the behavior of the output corresponding to a number of code patterns is the intended one.
I'm starting to wonder, like, why is it that Rust itself, or even other languages like that, cannot just be enough? Why is it that we have to create a separate compiler to guarantee all this stuff? And why is it that Ferrocene needs to exist? I mean, couldn't Ferrocene just kind of add these capabilities to existing Rust so everybody can enjoy this?
I think this is a frequent point of misunderstanding. So Ferrocene we consider a downstream of the Rust compiler, and any changes that we may find that need to be done to the compiler. So we're searching for bugs and issues here, and bugs and issues that we find, we're going to upstream back. There's multiple reasons why you want to carry a downstream. And those are mainly pragmatic. Like, for example, we do work on a closed source operating system, and we're providing a target for that. And so to go a little bit deeper into that, so the way you do that testing is you usually talk about a configuration. So you say, we make sure that the Rust compiler of this version on this specific kind of operating system is of high quality, and that we know of potential issues that we can communicate to customers. So that means we, for example, need to do testing on a target that we cannot disclose because it's not available to the open source project. So that's the kind of interplay there. And the other part is customers in that space often need support for that over very long periods, literally talking in the tens of years. So the other part is they want a supplier that guarantees, say, we find an issue in 10 years with the break that we talked about, and we have built this specific piece of software with this specific version of the compiler that you ship to us. Do you have an engineer available that could go back to this old version, find exactly the bug that triggered that, and fix that? So the service is very different. And that's a service that's hard for an open source project to bring. That's why people are looking out for a vendor. But it is very common that those vendors do actually use open source code and contribute any kind of changes back that they find. So it's more like a very specific tightened quality control on certain aspects of that compiler rather than a complete change there.
So it sounds like to me it's like you guys sell like an LTS, something like that. And like you said, if that specific version is busted, you will fix that specific version and then send that back to the customer or your client to actually use, like you said. Am I understanding correctly now?
It's part of it, right? So the other part is all the demonstration that shows that this compiler is suited for purpose.
And that purpose would be very safety critical or mission critical types of things, like you said, aviation, automotive, military equipment. These ones have to have very stringent, high quality things. And that's just like kind of building upon. So you take the existing open source version of Rust and kind of harden it a bit. Is that right? To really make sure that, or not maybe document it a bit to make it really good, because you're saying you're taking it and you're downstreaming it, right? It's like a superset.
I wouldn't say document it a bit. It's actually quite a lot of documentation and demonstration that is required to achieve the level of demonstration that is required. And just to make things a bit more concrete, what happens in safety critical is that you develop new software, you select your tool environment, you compile on other tools. And then at some point, you want to deliver and run that software in the environment it's intended for. So for example, you have a car, you give that to your OEM and piece of software to the OEM and you want the car to run, or you have a plane and you want the plane to fly in the civil airspace. You have bodies, authorities, TÜV, for example, or maybe the FAA in the US or the EASA in Europe for planes. And those bodies will not accept to let you run your software unless you have all the demonstration that is necessary, formatted in the right way, with access to the right people to explain and so on and so forth. So there's actually a very significant amount of work to bring things, documentation, testing, demonstration, to the level that these people would accept you to doing what you're trying to do.
Like, how much are we talking about in terms of like showing proof that this is going to be correct? Like, because I see Florian very happy about this kind of question. I'm just kind of curious. Like, I can imagine, right? Because I understand like these are things that could kill people, like aviation, automotive.
Let me use the question about quality on an on-ramp, because I think this is something where sometimes the discussion is a little bit off. The REST compiler is a quality product, that without question. The thing that the industry there needs is not just quality, but also quality management. That, for example, means for all of these kinds of, to ensure safety, they need certain activities to be done. And those could be writing a test suite or fixing gaps in the test suite, or just making sure that why are the tests even there? This is, for example, a question that we're currently working on, is this huge array of tests. Is that covering everything that we need? Are there gaps in it? Just that amount of work, even like just building the map out of it, is one thing. The other thing is also anything ongoing. So let's theoretically say we have a vehicle out there, and we know software has been built with a certain Rust compiler, say version 172 or something like that. And 5 years in, we figure out that there's a miscompilation in the Rust compiler that may lead to faulty code. The Rust compiler does miscompile a certain kind of code. What's the job there is then figuring out, does this thing that was figured out, that was found in the future version, does it affect this version that was used to compile code for that car? And if it does, actively inform that company that they should be aware that the compiler they've been using could have affected this piece of code, and give them all kinds of tools and support to figure out whether that's true, or to rule out that they're not affected. So that's the other bit there. So it's a frequent discussion that I end up in that the product there is not just the compiler, but the making sure that tool users, that every activity is taken, or any kind of effort is taken to make sure that code is safe today and in the future, in that sense.
And to complete that, one of the outputs of the safety qualification work that we're doing on the compiler will be, hey, you're using this version of the compilers. These are the features, these are the capability, the language pattern that you can use. And these are the ones that you can't use because we determined that it was too difficult to demonstrate their safety and so on and so forth. And that also, that kind of study is also significant work, and is asking people, independent people, right, to look at the code, to try things out, and to identify what is suitable or not. This is not something that you have as part of the Rust compiler baseline.
Okay, because yeah, I'm just trying to think. Let's just say like if this thing is fixed in the next version, just ask those guys to just upgrade, right? Because they need all that proof and certification, right?
There's two issues here. The first one is you need that proven certification. So we would need, with Ferrocene, we're going to upgrade the toolchain, frequently, but not to any arbitrary version of the compiler. So that's the first aspect. The second aspect is that typically in those industries, if you look at avionics, for example, you select a compiler one day and you will use that compiler for 10, 15 years maybe on the highest criticality and the most stable environment that you might have. So you don't want to upgrade to a newer version that's several years younger, because even if you know which bugs have been fixed, you don't know yet which bugs have been introduced.
Yeah, I was just thinking about that, and it's kind of like you cut off the serpent's head and you have two more coming out, something like that. That can happen, right? But if you do have like a huge suite of tests that you're running, yeah, I guess you're saying even if you have the huge suite, you may not be covering that situation, right?
Yes, the thing with those demonstrations is that in essence, they're never complete. So what you're trying to do is to mitigate as much as possible the odds of issue, and you're trying to provide mitigation for what happened when there's a problem. So that there's a two-dimensional aspect to it. But it's never perfect, and you know that there could be errors beyond that. Another aspect that's important is what we call quote-unquote proven in use. So that means that on top of these two aspects, what you want is to be using a compiler on a technology that others that are in the same situation as you are also using, so that the odds of finding a problem on that specific version is increased. Let's take the example of aviation. If Airbus is using the same compiler as Boeing, all of a sudden, if a problem is found on an Airbus site, then we know that this is going to be a problem in Boeing, and that also helped to increase the confidence. So jumping to arbitrary version of the compiler, may they contain targeted fix, is something that generates a lot of anxiety.
Now, here's a good question, right? You can still say the same thing, right? If upgrading the version of Rust would actually fix that bug, but like you said, you don't know what's going to happen. But at the same time, if you fix that bug, you don't know if it's going to happen again, right? So how can you justify just upgrading that version, or sorry, fixing that version will not cause more problems? How can you justify that?
That's the whole idea of mitigation of issue and targeting. So on those versions, we would limit as much as possible the changes that you can do to those that we call safety critical. So yes, you might say that any change is a possibility of introducing a problem, but what are the odds? Changing a few lines of very targeted codes on an environment that's under control versus, the front of the wave of the Rust compiler when people are actively developing and adding new capabilities. On top of that, of course, when you do that very targeted fix, what you do is also rerun your entire tests, corpus, and everything, right? So you have some level of confidence that the odds are low, but it's never a 100% bulletproof demonstration.
Okay, I think that's a good point, right? So Ada has been a language that I understand, at least when in my research, that it's really for this purpose, right? For these types of problems. Like the history of Ada that I understand is like it was for like the military. They wanted to kind of have like, they had like 370 languages, it went down to like 78. And obviously Ada was one of those. And like Ada's been working fine for what, at least 30 years or maybe more than that? Like why all of a sudden you need to bring a new language to the mix? Is it because it's trying to replace the version of C that was out there? Because I did see Ada does sometimes pair with C. Can you explain this?
So that's an interesting question. And languages is always a touchy subject, that generates a lot of passion, sometimes without reason. So the history of Ada is that it was very, very big, let's say in the 80s, early 90s. But at the time, the toolchain wasn't really quite there. It was very slow. It was not up to standard compared to other compilers. Up until mid-90s, there wasn't even an open source compiler for Ada available. So whilst the language was on paper very good for safety critical and mission critical purposes, people grew frustrated by it because they had to cope with toolchains that were not at the right level and that were very expensive. The US Army made that even worse by mandating the usage of Ada for defense contractors. So people really had no choice but to use that. So that mandate was dropped in the mid-90s, and at that time, there were C and C++ compilers around. A lot of the industry decided to move to other languages, which means that as a consequence right now, if you look at the Ada usage corpus, it's a lot of the military, which is coming from that era, plus a couple of places where people have had interest into increasing the safety, and I found Ada as a big help. And taking the example of NVIDIA, for example, that has in the past few years moved to Ada and its formerly proven version Spark to develop safety critical software. That being said, there are still a lot of people out there and a lot of situations out there where the look and feel of Ada doesn't quite matches the development style that they would like to do. Ada is also a specification heavy language, right? You specify a lot. If you compare to C or even Rust, you'll have to define type ranges, right? So this is an integer that goes from 0 to 10. You'll define pre and post conditions at specification level. This is the expectation prior to calling this function. This is the shape of the result, and so on and so forth. All of that is great if what you want to do is to solve the issue of, I would say, low-level specification at the language level, and you're happy for a language that looks a little bit different than C, more like Pascal. But to some respects, it even be a matter of taste. And it's interesting now to have another language, which is Rust, which also is very heavy in the wish to increase and raise the bar in terms of safety and security. In particular, the way Rust is tackling the issue of memory safety is remarkable. But with a syntax that is perhaps closer to people that are accustomed to C. So it's difficult to answer to the question, why not Ada, why Rust? I think there are a lot of factors that are coming in to justify the decision to go one way or the other. AdaCore, we are interested into supporting both communities. But I think there's another interesting question that might be asked beyond the which one to choose is why now? Why Rust is a thing now and not, let's say, 20 years ago? And I think this is a symptom of the fact that a lot of industries are raising the bar in terms of the safety and security expectations of the software that is being written, right? If you look at just security, for example, the sheer amount of security backdoors that are opened by something as trivial as a buffer overflow, this is staggering that in 2022 we're still talking about these things. So that's for security. For safety, autonomous car and driving assistance is bringing software at the core of the safety function of the car. This is new. This wasn't the case necessarily, 15 years ago. So I think this is also a symptom of the fact that there are more and more people that needs safety and security in their products. And as the market is expanding, the fact that there are alternative solutions to reach that goal that allow people to choose one or another depending on the subtlety of the strategy that they want to follow or to the subtlety of the problem that they're trying to achieve. I think this is an extraordinary positive aspect and move.
I kind of want to talk a little bit more about Ada because I think a lot of people don't really know what it is. And actually, I had a big question about it too because it makes a lot of guarantees, right? That was kind of like a big thing about it. Like you said, you specify a lot when you're writing Ada. Now, the biggest question I have to me is like, is there a VM or something, or does it actually compile to a binary like C or Rust does? Like, I want to just know just a little bit more about what Ada is and how you deploy it, this kind of stuff.
It's funny that you would ask that question. I remember a few years back, I looked at I think it was .lang.com or something like that, and there was a paragraph that was saying of the like, Rust is a system level language. It works without a garbage collector. It is efficient. It's natively compiled and this and this and that. And I just replaced Rust by Ada, and I had a perfect positioning of the Ada programming language, right? So it's natively compiled. It can be used in embedded system. We have cases of people that are using Ada on AVR 8-bit microcontrollers with no runtime, for example, for the smallest, up to people that are running Ada on large servers. And from a compilation pattern standpoint, it's very close to Rust. It's very close to C and C++. This is the same family of native languages.
The main reason that I asked is because like I was reading about it and I can't remember, like when I was reading, I felt like, does this thing have a VM or something? Because like it said like there's a lot of tasking and things like that. So I'm thinking there's like a runtime to it.
You can have a runtime to support tasking. That's not a virtual machine, right? That's just semantics for threads and semaphore that you have in all languages with a little layer in between to implement the Ada semantics. But you have that in many languages, and then the implementation depends on the target. For example, if you have a real-time operating system underneath, then we would implement that directly on, pthread, for example, or Win32 API. If you bare metal, we would provide a microkernel to implement real-time. But it's still very far from the concept of a virtual machine.
Okay, thanks for clearing it up because I was just like, what is this thing? Because people don't really talk about it so much. There's actually a lot of videos on YouTube actually how to use Ada. So I was a little bit surprised. So actually people are using Ada for like what you guys are looking to use Ferrocene for, right? Like these like aviation. I know they use I think they use Ada for like aviation systems, like routing the planes, but like extra like hardware of the aviation planes themselves, right? Okay, yeah. That's exciting.
I'll tell you what my favorite thing in the AdaCore office is. It's that one advertisement picture that's just a picture of the ISS and the name of the company. That kind of describes like where it's being used.
Yeah. So actually now let's kind of going back to the core topic, right? What brought you two together? Was it like you guys walk into each other in the subway or something? Or how do you guys actually manage to hook up together? That's the curious part. Because Ada's been working fine for a long time, right? And you guys have been, I mean, you're a rather large company, I think. And it's like, why are you looking at Rust? Or did somebody bring it to you? Or I know Florian's a guy who's always networking, so maybe he's just kind of always pounding on your door. I don't know. What brought you guys together?
Maybe I can start answering that then.
Sure.
So first of all, address one thing. I've heard the sentence in the discussions last year, oh, Ada, that's the proto-Rust, by one of the Rust designers and early project managers. So the languages are very close in value. And as you may have seen, AdaCore has been blogging about like, oh, this is how you do something like exploring Rust on their blog for quite a while. And the first time we actually met was when we just went to Embedded World and got ourselves a booth there just representing Rust. And there was a lot of interest there, and AdaCore was just down the hall and actually dropped by, and we had an interesting conversation about our view on where the industry is going. And the one thing that was interesting was that from both sides, we felt like there's an air where the industry is actually thinking about, okay, how can we get rid of our memory on safety problems? And there were two languages always in that discussion, Ada and Rust. So we've seen that a lot. So we started, that discussion back then, and maybe that's for you to take over. That this was actually AdaCore that actually got in touch. So
we've been fascinated by Rust since we heard about it, because here comes a programming language that seems to try to achieve what we've been trying to do and put to market for all these years, but it's doing it differently. It actually brings refreshing ideas to the market. It brings refreshing ideas on how to do things, both from technical perspective, but also to the community aspect, the way to handle it. One example amongst other, this is an LLVM based compiler, at least today. Ada was GCC. The Rust community was at the time much more open than the Ada ones. We've tried to open up a bit more since then. So we were very curious about what was happening. As a matter of fact, we got some inspiration from Rust in one of the latest versions of the Ada language. In particular, we tried to replicate some of the ownership because we found that was extremely useful, and a shame that Ada didn't have that capability. So that always was something that interested us. And when I say interested us, I really mean at all company levels. When the word got out within AdaCore that we were going to start working with Rust, we got a lot of open eyes at the engineering level. People were asking questions, people wanted to get involved, people wanted to contribute or follow what's happening. So I think there is a very strong compatibility in terms of what we do, how we want to do it, what we want to achieve, that just made the collaboration and the relationship organic from this point on.
That's pretty interesting, right? So what I find really interesting is, like you said, you already have something that's really comparable to Rust. If I understand correctly, like you're kind of saying, well, the dialect is different. The guarantees are there, but the dialect is different. And some of the things are done a little bit differently, but overall the essence is about the same. Maybe I didn't say that correctly, but that's kind of what I feel based on what you just said. So I was kind of curious, like, why, you guys have your own language. You've been working just fine for a while. Like, why decide to open up and say, okay, maybe we're going to also support this other language? Maybe I cut you off too soon, but that's kind of my main question.
No, I mean, it's fair to say that a lot of people are adopting the Rust language, and a lot of people are looking at using the Rust language for safety critical purposes. If there's one thing that I learned, I've worked for AdaCore for about 17 years, right? And across those 17 years, I have not managed once to convince anybody to use the Ada language. I tried many times. That never worked. So what that taught me is that as a company, it's near impossible to influence that specific choice. It comes from, you can provide documentation, you can provide information, you can sort of provide advocacy, if you will, but your actual influence as a company is fairly limited. So when you look at our goal at AdaCore, our goal really is to support this market of people that are interested to develop safe and secure software. We call it software that matters, right? And if people are selecting the Ada language, great, we want to support those people. But if people are selecting the Rust language, we absolutely want to support these people as well. And actually, we agree that Rust is a fantastic option for developing this kind of technology. So we want to be able to be supportive of that market as a whole and not only on one specific niche.
So Ada is not going away. Let's make it clear, right? Ada will be around forever. You still have customers right now, I'm guessing.
It's a very strong language. One of the reasons why it's very strong is that the profile of users that have selecting the Ada programming language have looked at applications that span over decades. And they need this programming, this code base to survive through generation of hardware, generation of programming practices, and so on and so forth. So our main job at AdaCore for a long time was, let's make sure that if you want to keep your Ada, you can, because we're going to support the latest environments, we're going to support the latest targets. We added support for RISC-V recently, and so on and so forth. So that Among Us base of user alone is guaranteeing the existence of the language for decades to come. On top of that, alongside of the start of the Rust language, the same thing that led people to develop Rust and to adopt Rust, which is the increase of the market, increase of the safety need in the market. That same thing has also brought us new Ada and Spark users. I'm saying Ada and Spark. Spark is a version of Ada that allows to do formal verification. So it's sort of Ada plus plus, if you will, in terms of confidence. So if you look at a company like NVIDIA, for example, they're coming from that sort of second wave of adoption, people that had no prior exposure to Ada, but they had those, we need to raise the bar in terms of cybersecurity, we need to raise the bar in terms of safety. Oh, Ada has been around for a long time. Maybe that's what we should adopt. And here too, you could see a trend and you could see something that is quite solid and that's going to go across the years.
Okay, so now with this partnership between Ferrous Systems and AdaCore, what does that mean to AdaCore's business? Is it like when customers come to you and they say, we need to build stuff in a very safe and critical way? Is it that you guys kind of open up your say and say, okay, do you guys like C already? So then maybe you should take a look at Rust? Or is it that what is it that you guys are doing now that's changed now that you guys have this partnership?
Usually, at least from an AdaCore standpoint, when people come to you, they already know the language they want to use. Or if they don't, they already know that the language they want to study. So people would come to us and say, hey, I want to start working with Spark, Ada. I want to start looking at that. We also have people that start coming to us and say, hey, in particular in our user base, hey, we've seen that you guys are doing Rust. That's great because we also want to look at Rust. So you see that that's really where we plug our value proposition, I would say. We don't get many people that, if any, that come to us and say, hey, I want to do safety critical. What is your advice? Usually we get contacted at the next step. If we were contacted at that step, that might happen, like somebody that really has no prior conceptions, we would just go on describing the options that are available to them. Maybe the case that they like one more than the other. As a matter of fact, we already have customers that adopted both very recently. So that's also an option. That, again, depends on many factors that often are beyond our reach. The one thing that we can safely say is that if there's a way to move out of the C language, then they're going to be a big win. Because the one thing that you will get by selecting either Rust or Ada is that you will fight a lot less against the language to reach your safety goals. But beyond that, there is a lot that depends on the context, company culture, and factors like that.
So how does this partnership between the two of you guys actually work? Is it that like when you have Rust stuff, you'd reach out to Ferrous Systems to kind of help support that? Or is it you guys are putting money into Ferrous Systems? Because I think Ferrous Systems is relatively smaller than AdaCore, right? So I'm kind of curious about can we talk about more details about how you guys are actually working together on this?
All right. I have one thing to add about the comparison of the language. That's been a frequent issue that I had, even in my part of the community team. It's I think a lot of language discussions are very shallow. And one of the things, for example, about Ada is particularly that formally verifiable Spark subset, which is pretty much unique in the programming language world. So if that's what you want to do, I know there's projects in the Rust space that are inspired by that, but they're not here yet. Spark is here. So that is these kinds of customers are choosing their language now because they want to start developing now. And that's often so, and those things are often a deciding factor. On the relationship between the companies. So what we have done is we turned Ferrocene into a joint venture, a classic one. So both companies will bring their share of work to this, paid by early customers. So we have early customers that are helping us particularly to reach our goal to bring the Rust compiler first to the highest criticality levels of ISO 26262. That's ASIL-D. So Ferrous Systems brings is our Rust experience and expertise and our particularly around infrastructure, testing, all of our knowledge about the compiler and all of these kind of things. And AdaCore brings their experience in making qualification happen, the project management's experience, their experience in running a downstream to an open source compiler, GCC, since multiple decades. So a lot of that procedural knowledge. So I can share that one of our early project planning meetings was for me an exercise in, Florian, all your ideas are good. Let's reorder them and let's make sure that you reach some goals early and some we push to the back. So it's especially the experience about dealing with the same project space, and it's pretty small amount of companies that engage here, and we're newcomers. It's not like you bring a new language up into the safety critical space, do all of these qualifications every year. So it's that pool of experience and efforts and activities. And it's a classic joint venture.
I'm now kind of curious because you just helped me to remember that AdaCore works with GCC. Does this mean that AdaCore is going to be contributing to Rust working with GCC, or is that not a come and go?
It's difficult to say at this stage, but yes, in the galaxy of the possibles, looking at Rust in the context of GCC is something that might make sense. I would say that for customer basis, a lot of people would be interested into carrying using GCC. So although that's not something that we are working on right now, that is part of the possibility that we're looking at.
Yeah, that's always been kind of an interesting topic. Like there's basically two different projects that are working towards this goal. Each one has a different way of looking at it from what I understand. And I know GCC is popular because, I mean, it's been out for a long time, highly tested. I mean, you guys are working with it. Obviously, LLVM is super recent, right? And so working with GCC will probably give you a little bit more of, not an edge, but how do you say that? It's been battle tested a lot longer, I think, right? So I can see that would be something that maybe you guys want to look at, but Quentin, you seem to have a different idea.
Yeah, I'm a little bit uncomfortable by the idea that GCC is so well tested and LLVM is not. LLVM has been around for a long, long time as well and is being used in safety critical situations. I'm not sure if that is as much as a differentiator today as it would have been perhaps 10 years ago. I think the difference is more, what is your experience as a company, as a user? Are you experienced in a GCC heavy environment? Are you accustomed to the programming patterns? Is that the compiler you want to use? In which case, it might be good to have everything using the same backend, although you can mix LLVM and GCC. So I think that's one factor that's a bit more important than the quality, which we led to believe that LLVM is at the right level today. The other aspect that may come into consideration one way or the other is that there are certain hardware targets that have better support for one or the other. So for example, I don't know what's the situation today, but for a long time, the LLVM support for PowerPC was not high enough. So people that used PowerPC, I see Florian confirming. So people that wanted to target PowerPC needed GCC. So if one day we have to do PowerPC for Rust, in ensure context, I think we'll open the question. But those are contextual answers. From a quality perspective, I would really not differentiate the two backend at this stage.
Yeah, because like I said, GCC has got so much more history, and I think it's a little bit more predictable or something. That's just my understanding. So I can understand, like, if you have a client come to you and say, we want to use Rust, but we would like to use with GCC, can you guys support us, right? Would that be something that your distort venture may actually take a look at, or this is just like maybe a wild dream while out there?
No, it's not a wild dream. I think be open to the prospect is definitely something that would make sense in some situations.
I'll take that opportunity to say how we work there. It's like when we're talking about these kinds of configurations that I've been speaking about before, we generally support them on customer request. So if someone were heavily interested in that, please let us know and we can talk. One thing that I would like to highlight, because I think PowerPC is a great example on how subtle this gets. I mean, PowerPC is the old Apple target, and LLVM generally supports PowerPC, but there's specific PowerPC profiles in the areas that we're looking at. So, for example, there's special instruction encoding that has a shorter instruction length. I think they call them short instructions even on PowerPC.
Really?
It's similar to ARM thumb. That isn't supported on LLVM and only supported in GCC. So it may even be like the target is generally well supported on LLVM, except the particular features that are needed in the industries where we are. And that comes back to the whole idea of pooling knowledge. You could support that on LLVM, but then you're the odd one out and the only one that's actually working with that feature. And that runs against the idea of safety happens if a lot of people are using that and, in a sense, share the bugs. Because a bug that you know about is something that can be mitigated. A bug that you don't know about is something that cannot be mitigated. And that's also, I think, one of the things that is not often enough mentioned in that conversation is it's not like this is all about software with no bugs. This is about software with known bugs. And how do we deal with them?
I kind of What you said about the mitigating its bug kind of rings like this familiar tone I heard from Linus, where he said a bug that feature that people rely upon is no longer a bug, now it's a feature. Just kind of remind me of that saying, which I think makes a lot of sense, right? So yeah, I mean, I think would be a very interesting stuff. I think this will push Rust into a lot of new areas, right? So you have two companies that are really known for two companies, like you got one company that's really known for that safety guarantee and kind of providing that support. You have another one that does the same thing. History is not as big, but you guys know obviously the most about this Rust language and LLVM and such. And I think that would be awesome partnership. Like, I'm kind of curious, like, how many people have approached AdaCore and said, we want to do this? Can you, like, we're ready to do this now? Like, can you help us?
Do you mean from our existing customer base?
Actually, I would like to hear numbers if you have any, or just a rough idea, like how many from existing and how many new customers kind of came to you guys.
So the way it works is that right now, new customers are more starting to talk with Florian. The existing ones are more starting to talk with us. I don't know that we can share numbers at this stage, but it's a significant portion, on our end at least, of our user base talks to us about Rust. And we also realized that when we published the blog post, like we got a lot of people saying, hey, great, you know what? You're doing that? We have Rust. Are we looking at Rust? Are we planning to use Rust? Are we curious about Rust? Tell us more. So yeah, that is significant.
I can share a tiny bit there. So in general, people approach us. We've been blogging about this for quite some time, and we've always set as a separate communication channel. So people generally approach us through that communication channel, and that communication channel is now covered by AdaCore and Ferrous Systems, both. So that's the shift there was pretty simple. So I cannot talk numbers, but I can talk a little bit about what the usual profile that's in touch is, if that helps as a supplement.
Well, I mean, even if you can't talk numbers, like I'm curious about, like, I mean, Quentin definitely said, hey, it's significant. So I can understand what that means to a certain extent. I'm just kind of curious about, like, is it just 1 to 10 or something like that? Like, I don't know, maybe you don't have to be so specific, but it's the fact that you say it's significant means that there's definitely a market and it's something there.
So, I mean, if I were to drop a number, we've been, over the years at least, been in touch with 60 or 70 companies. But the question is always like how qualified it is. And the interesting thing is it moved from, we blogged about it and there was some engineer reaching out to us and saying, hey, this is really interesting and I would like my company moving there. And then sometimes it's a project manager in the R&D department, and suddenly it's people in pre-production, and suddenly it's people in production. So this kind of ramp up we've seen over the years, and that has actually been the same thing as we had in the early days of Rust. You had curious people within companies, and then it moves up the management chain. So the usual people who currently get in touch are newer automotive companies. So either parts of larger automotive companies or new startups which are building new car platforms, particularly for autonomous driving. That's the usual ones that get in touch, but also classic older companies in the aerospace industry and in other safety critical parts. But our main focus currently is automotive. And that isn't surprising because automotive is currently in a phase where it's reassessing all of its software, particularly because all cars become connected. And that brings the problem of suddenly we don't only have the issue of safety in the sense of does my brake work correctly, but also all the cybersecurity issues. So all of these issues become less separated than they've been before. And that brings an environment where people are looking closely at their software stack and reassessing. And that's an opportunity for Rust and for Ada as well, because the moment people are are reevaluating, these kinds of things happen. They look at all the languages. I've seen tables on how they do that. I've seen a table over 5 years where people were tracking the Rust language and they had their desires listed down and they were looking at it every year to see if there's more checkboxes. So if the project is moving in the same direction. That was quite fun. That was 2 years ago. Looking over the past 4 years, seeing like how more and more of those checkboxes ended up in that list. So it's people have been looking at that for years. And we're seeing more and more that they're getting serious about that last year and this year. So I'm looking forward to actually be sharing some of those names in public. But yeah, that's all I can currently say.
If you don't share names in public, that's totally fine. I respect that. And same about the numbers. But what I would like to hear, and I hope you can at least say this, is there any interesting industries that you never would have expected that's actually coming up into Ferrocene looking at this? Has actually contacted you guys?
Yes, I am surprised on how many people approached us, and that's more than zero, about using a high assurances compiler in places where they don't need it for regulatory requirements. I think the thing that you've been doing with NVIDIA is a good example of that, like where there's the need for high assurances just for cybersecurity reasons. And I wouldn't have expected those two approaches.
I mean, like, so for NVIDIA, that's not GPUs, right? It's actually something else.
Yeah, so there's actually a public story out there. We can give you the link if you want. NVIDIA has a mixed need. They're developing firmware around the GPU, and some of it may end up being safety certified product because they have the drive platform, which is targeted at autonomous vehicles. And some of it is also for general purpose cybersecurity. So they have both needs actually, and they have been using Ada and Spark to cover both, not only the safety critical ones. That's a pattern that we've seen a lot as well. People like to be almost certification like, right? You don't have regulatory constraints, but you want to work as close as possible following the same processes because you know that it brings the high level of confidence. So maybe you don't need, we see that a lot in defense actually. So maybe you don't need all the heavy documentation on your desk because there's nobody to show it to. But you would like to be using the same compiler as those that do need documentation so that you have trust in the fact that you're using the right version of the tools and the right methodologies.
I'm kind of wondering if it kind of like that general idea where it's like you buy a printer and you buy the warranty for it, although when you go to, it makes you feel better, but actually the warranty doesn't do much in terms of actually kind of protecting you against some stupid error. Or you buy the warranty for your iPad, but you drop it, the screen's busted, you can't get it fixed. You have to buy a new one.
There is some of that to some respect. Yeah, absolutely. Some of that.
I mean, again, the thing about the quality management, for example, you're a bank or something. So your software system, like failure in your software system may cost you just a lot. You may want to invest some amount into using something that's thoroughly tested on the kind of hardware profiles you use, and B, something coming back to this is a rarely spoken about but highly valuable part. You may want to work with a vendor that will actively inform you of issues. In my previous enterprise, I've maintained a lot of database systems, and I can share like the most professional database vendors, like the MongoDBs and the Elastic and whatever. The reason why you pay them a lot for running a node is exactly the same, because they will actively inform you if they see your particular system running into problems. And that's just a more than worth the amount that you're paying them. Because if you're running into any of these things that they warn you about, that might mean downtime of hours. And if you're running, for example, a web shop, it may just be a lot of money. So it's these kinds of calculations. And I can share that a lot of people are very thorough about making these kinds of calculations. Like, is that worth the investment or not? So,
yeah, I think that's a really great example, I think, because like you said, a bank, right? Every second is money, right? And if they can't trade or whatever they would be using Ferrocene for, it's a big problem. That makes a lot of sense. Yeah, I think you guys definitely helped me to really understand and figure and understand why is it that you guys came together? What's the value you guys are bringing? What is Ferrocene is probably the biggest, the biggest thing that I think I really got out of this. But also I can see why is it that you guys are working together and how this is actually a partnership for mutual interests, not just for both of you guys' companies, but actually for the whole entire REST community. Basically save us from C, right? I think is the biggest issue. And let us work with something that's really nice and really performant like Ada or Rust. And I think that's big enough by itself. Is there anything that you guys kind of want to part with before we start to sign off?
I think that's a great summary, Ellen. I wouldn't say it better.
same from my side. Happy to answer any kind of questions. If anyone heard this and still has questions, please send us all an email. We'll do that. And more than happy, and it's been a privilege to follow the Rust ecosystem grow into all of these kind of spaces. And Ferrocene for me is a little bit of the, okay, let's put something on top of that. Let's literally fly planes with Rust.
Yeah, so fly high with Rust now, right?
Yep.
Yeah. Do you think you'd feel safer if you knew that the plane you had that you were on was actually built with Ferrocene?
I'm not sure if I can answer that question because I know planes that I'm aware of that are built with Rust. And one thing that I observe in the safety critical industry is like they're not interested in abstracts. They're interested in like, is the exact thing that you're running on a plane safe? But I can share it's been a good experience flying to New York to a company that would ask you which plane you flew in because they know the software that's running on it. And knowing that people care about it in that level of detail. So
Yeah, that actually feel a little bit freaky, but at the same time, it does kind of make you feel, wow, it's a small world, that I've been interacting with this company indirectly for a while now, and I'm still alive. That's good.
Yeah, that's a good summary.
Cool. Yeah, I think if I don't have anything else, then you sure this is your last chance? Anything else you wanted to say?
We're good. Thanks for taking the time.
Yeah, thank you guys for your time. Maybe we can come back after Ferrocene's been out for a while and see, what's going on. If you have any numbers in the future you guys can share, I think that would be really great to see. More companies are probably, if they see some good numbers, they'll probably be jumping on board, right? Thank you.
Thank you.